Alright, good morning class. I hope everyone is happy, healthy, and excited to learn the lesson today, which is on relations and functions. Okay, suppose you are speaking with a man, or you are talking to a man, and then suddenly both of you saw a boy, and then the man points to the boy and says, that boy is the son of my wife. Okay? And then he'd ask you, what is my relationship to the boy? If he is the son of my wife. Simple logic would tell you that the boy is the son of the man, and the man is the father of the boy. So you see a connection or a link or a relationship between the two, the boy and the man. Okay? In set theory, a relation is a way of showing a connection or relationship between any two sets. Now, these two sets must be non-empty, and we note that the subset of the Cartesian product also forms a relation. Remember the Cartesian product A cross B we had last time? And also, a relation may also be represented by the Rosser method, where we list all the elements, or the set builder method, where we define the property of the elements of the set, which we denote by P of X. So suppose we are given the sets A and B with elements listed here, okay, and the elements of set B also listed here, 1, 2, 3, 4, 5. And we are asked to form the set R whose elements are ordered pairs XY, where X can be solved using this equation 4y minus 3, and X must be an element of the set A, and Y must be an element of set B. Okay, so suffice to say, this tells us that we should choose first the value of B, or the value of Y rather, from the set B, and solve for the value of X using this equation. So suppose we choose 2 as our B, okay, what will be the value of X? So we substitute 2 here, so that 4 times 2, that's 8 minus 3, that's 5. Okay, so we have the ordered pair 5, 2. We check if 5 is an element of set AY because it is given here, it's a rule that X must be an element of A. True enough, 5 is an element of set A, and to check again, 2 is an element of set B, and therefore 5, the ordered pair 5, 2, is definitely an element of the set R. Suppose we choose 3 as our Y, no? So 3 is an element of set B. So we substitute Y with 3. So 4 times 3, that's 12, minus 3, that's 9. So we have the ordered pair 9, 3. But look at set A. Okay? X must be an element of set A. 9 is not an element of set A, and therefore the ordered pair 9, 3 cannot be an element of R. Okay? If we choose Y as 4, or we choose 4 as Y rather, we substitute 4 here. So 4 times 4, that's 16, minus 3, that's 13. And check if 13 is an element of A. So again, it's an element of A. 13 is an element of A. Therefore, the ordered pair 13, 4 is an element of the set R. Okay, so we have here a diagram showing the relationship, no, between the ordered pairs 5, 2. So this is the set X and this is the set Y. The element, which is the ordered pair 9, 3, and the ordered pair 10, 4. So what are the types of relation? Okay, so again, a relation is a connection or a link between two non-empty sets. Okay, so though the sets must be non-empty, there is what we call an empty relation. So if no element of a set X is related or mapped to any element of X, then the relation R in A is an empty relation. Okay, suppose we have the set X where the elements are parents, and set Y where elements are children. So a couple who do not have any children will have an empty relation with the set Y where elements are children, simply because this couple do not have kids. So that's an empty relation. Okay. What about a universal relation? A relation are in a set. So say set A is a universal relation if each element of A is related to every element of A. For example, we have R equals A cross A. We also call this a full relation. A classic example would be the relation between the natural number, or the natural number and the whole number, or counting number, natural number and counting number. So they both have the elements 1, 2, 3, and so on. Elements 1, 2, 3, and so on, meaning they are identical. So an empty relation and a universal relation are sometimes called trivial relations. What about an identity relation? An identity relation is one in which every element of set A is related to itself only. So we have this notation, the identity relation of ordered pairs AA, where A is an element of the set A. So what is the best example? So suppose we throw two dice. So dice is plural, no? The singular word is die. So if you have this single cube, that is a die, D-I-E, and the plural is D-I-C-E. So when we say dice, it means more than one die, okay? So there are 36 possible outcomes. So we have 1, 1, 1, 2, and so on, no? So if you count all of these, there are 36 possible outcomes. However, we only want the identity element. So what is the identity element? Both dice have the same outcome. So you have 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. So there are only six possible identity relation. What about the inverse relation? Okay. So it is a relation from set A to set B, where R is an element of A cross B. The relation inverse, no? R inverse is said to be an inverse relation if R inverse is from set B to set A instead. Okay? So from original BA, it becomes AB. So remember our example before. So we threw a pair of dice. So we have the elements, the ordered pair 1, 2, 2, 3, for example. So the inverse would be 2, 1 and 2, 3, no? So you reverse the order. Okay, so that's an inverse relation. What about reflexive relation, symmetric, and transitive relation? So if every element of set A maps to itself, then the relation is reflexive. So similar to the identity relation, such that we have the ordered pair AA, which are both elements of the set A. So they form a relation. What about symmetric relation? A symmetric relation R on the set A is said to be one where the ordered pair AB becomes BA. So it's like the inverse relation we had earlier. What about transitive? So this time, you have the ordered pair AB, BC, and then from here, we say that A is related to C. Okay? So again, AB is a relation, BC is a relation, and therefore by transitivity, AC is also a relation, having A, B, C all elements of the set A. Now, if all three are present, reflexive property, symmetric, and transitive, we have what we call an equivalence relation. Again, all three must be present for an equivalence relation to exist. If one among the three does not hold, then the equivalence relation will not hold anymore. So for example, we throw a pair of dice, A, B, and note down all the possible outcomes. Again, there are 36 possible outcomes. Okay, so we have 1, 1, 2, 2, 6, 6 as reflexive, no, showing reflexive property. Then we also have symmetric property because 1, 2 can be presented as 2, 1. And we also have transitive property because if we have the element 1, 2, 2, 3. Then we have the element 1, 3, all of which are elements of the set, meaning all possible outcomes we had earlier. So we say that this define an equivalence relation. So suppose we have this problem. There are 3 friends. So we have friends A, B, and C, living near each other at a distance of 5 kilometers from each other. We define a relation R between the distances of these houses. Now, is R an equivalence relation? Okay, so how do we determine if R is an equivalence relation? We check if R is reflexive, symmetric, and transitive. Okay, so R is not reflexive because A cannot be 5 kilometers away from itself. So what's the reflexive property? A is mapped to itself. A house cannot be 5 kilometers away from itself. Okay, so the reflexivity property fails, and therefore this is no longer a relation, although it is symmetric because house A is 5 kilometers away from house B, and house B is also 5 kilometers away from house A. It is also transitive, especially if they are their houses is at a triangular figure from each other, so that the distance among the houses of these friends is 5 kilometers away. Okay, so transitivity holds, symmetric property holds. However, reflexivity does not hold, and therefore it's not an equivalence relation. Okay, now have you ever thought that a particular person has particular jobs or functions to do? Okay, so for example, I am a teacher, so I cannot put a fire because I am not a fireman professionally. I cannot sing, professionally, because by profession I am a teacher. So in mathematics, we also define functions. Okay, so a function is responsible for assigning every single object of one set to that of another. So we're now trying to define what a function is as opposed to a relation. So a function is a relation that maps each element x of a set A with one and only one element y of another set B. In other words, it is a relation between a set of inputs and a set of outputs in which each input is related with a unique output. So figuratively, using figures or diagrams, so this is a function, so a function does something to an input so that a specified output is yielded. Okay, so there must be a function is a rule that relates an input to exactly one output. So what can be the best example? For example, a person and his or her birth date. Okay, so a person only has one birth date. Okay, but that person can share the same birth date to other individuals. So that's a function. So there is a specific output. Okay, so there is a specific birthday for every person. So we say that a function is a special type of relation. Okay, so not all relations are functions, but all functions are relations. So it is a relation F from a set A to a set B if every element of set A has one and only one image in set B. As I mentioned earlier, so A is the person and B is the birth date. So there is only one image, there is only one birthday. A person cannot have two birthdays. However, a person can share his or her birthday with other individuals. So again, A and B should be non-empty sets. The whole set A is the domain, and the whole set B is what we call the co-domain. So for example, in our class, no, if I ask for your birth dates, so you will tell me your birthdays. Okay? So the domain is you. Okay? The elements are you and everyone in the class. The codomain is the what? The codomain set B birth date. So it could be any day of the year. So the codomain consists of the 365 days of the year. However, the birth dates, okay, will just be limited to your birthday. How many are you? If you do not share the same birthday, if you are 40, then we will only have 40 as the elements of set B, which we call the range. Okay, so the codomain is different from the range. Okay, so the exact value for B, no, which is assigned, no, from the set A is the range. Okay, so a function f which brings x to y is represented as f of x is equal to y, where the ordered pair xy is an element of f, and x is an element of the set x, and y is an element of the set y. Okay? For any function f, the notation f of x is read as f of x, no? And represents the value of y. So f of x is simply y. So f of x is the value of y when you assign a specific value to x. Okay? So the element y is the image of x under f, and x is the pre-image of y under f. Okay, so here, for example, 1 is mapped to 1, 4 is mapped to -1, 7 is mapped to 1, and 6 is mapped to -1. So suffice to say, odd numbers are mapped to 1, and even numbers are mapped to -1. So this is still a function y, because there is a specific element from set y for every element of set x, no, for every x element of set x. So it's like you with this birthday, no, you with this birthday, but you and this individual share the same birthday. Okay, so our body, no, the parts of our body can also define a function, no? So our hands can be used for writing, no, for clapping. No, we cannot use our feet for clapping, right? We use our eyes for seeing, so that's a functional relationship. We don't use other organs for seeing, only our eyes. Okay. So what are the types of functions? So we have injective, surjective functions. Okay. So this is not a function. Why? The first one is not a function. Why? Because this is you having two birthdays. That cannot be. You, this one is a function. Why? No. These two individuals share the same birthday. But the element from B is unique for each one. So this is still a function, a general function. Okay? This one is an injective, meaning one-to-one. So one is assigned to a specific output. No? So this is one-to-one. This is surjective. Every element of B has a pre-image. No? And this one is a bijective function, meaning one-to-one and onto. Okay. Alright, so recall that we can define a function as a special relation which maps each element of set A with one and only one element of set B. Both sets A and B must be non-empty, and a function defines a particular output for a particular input. Hence, we have this notation: f is a function which brings A to B, such that for every element A in A, set A, there is a unique element B in set B, such that the ordered pair AB is in F. So that defines a function. What are the types of functions? So we have a one-to-one function. So a function f from a to b is 1 to 1 if each element of a, if for each element of a there is a distinct element of b. It is also known as injective. So the birthday thing cannot be a one-to-one function. Okay? So how do we check if a function is one-to-one? So consider if a sub 1 is an element of the set A and a sub 2 is an element of set B. F is defined as f is the function which brings a to b such that f of a sub 1 is equal to f of a sub 2. So that's how we check a one-to-one function. Okay? If a sub 1 is assigned to f a sub 1, no, f a sub 2 must be assigned to f a sub 2. Okay? And this means that a sub 1 and a sub 2 are equal. So many-to-one function, it is a function which maps two or more elements of A to the same element of set B. Two or more elements of A have the same image in B. So many to one. So the perfect example is us having our birthdays, no, sharing birthdays. No? So that's many to one function. So what about an onto function? If there exists a function for which every element of set B there is or are pre-images in set A, it is an onto function. An onto function is referred to as a surjective function. In the vernacular, an onto function is described as something such that set B is used up, no, nauubos yung lahat ng elements ng set B. Lahat sila may pre-image, no? Lahat ng element, maaaring hindi mo magamit lahat ng elements ng set A, pero lahat ng elements ng set B ay magagamit mo. Meaning, lahat ng elements ng set B may pre-image. Ano yung pre-image? Yung elements ng X. So, what about one-to-one and on-to? Okay, which we call a bijective function. So, a function which is bijective is both one-to-one and on-to. Okay? So, this is the best relationship to describe romantic relationship. No? Dapat faithful. No? One boyfriend, one girlfriend. No? One at a time. Okay? So, that's a bijective function. So, here's a beautiful description of an injection, which is one-to-one. So, every element of X is mapped to exactly one element in Y. Okay? Though we may not be able to use up every element, as long as one element is mapped to exactly one element. That's a one-to-one function. So, this one, like I mentioned earlier, naubos lahat ng element ng set B. Each element has a pre-image, no? Each element has a pre-image. Okay? What about a bijection? So, this one is mapped to exactly one, and everyone has a pair or has a pre-image. So, this is the happiest romantic relationships of all, the bijective function. Alright, so that ends our discussion for today. Tomorrow, we will discuss other types of functions like identity functions, constant function, and so on. Okay? So, stay safe and stay healthy, class. Good day.